Good morning, students. Welcome back. So, collectively, people did very well on the exam, and I am happy to go over any questions that you might have in office hours. If there is a group of people that want to go through it, we can meet at some point and go through the questions. Some or all, totally happy to do that. But I no longer go through the exam questions in class because I just think it's not the best use of time. I'll do it for people that are interested. Okay. And good morning in the chat to Hind and everyone else. Thanks for turning your cameras on. To those of you who have, Otavia and Aries, hello. And looks like everyone has their camera on right now. But I do appreciate it. Anyone else is welcome to. There, Whitney, hello. Uh, to turn on cameras, and Lenny, hello. Uh, good. So if there aren't questions right now, we can move forward. We're going to look at the biology of the brain, and this will, in some ways, not resemble a philosophy course. But of course, philosophical issues are raised by the way we study the brain, different approaches. There are still some live debates that have not been settled. Uh, and thank you in a direct message. Um, so we're just looking at the kind of the biological background that informed cognitive science, neuroscience, largely at the end of the 20th century and the turn of the century and these past decades. The issues we're going to look at are, after a quick introduction, the localism and holism debate, which is still in some ways alive and well. In other ways, I think it's safe to say, certain aspects of the debate have been settled. Then uh, two different ideas about what the brain was. Is it a net or is it made of neurons? We now know it to be made of neurons. Then we'll look at the contributions of Lashley and Hebb, and finally our understanding of the neuron, um, at least as it was in the mid century. That's the mid 20th century, uh, and I may have some additional points to make. Uh, and we will uh, likely have some kind of presentation on brain imaging, but that's kind of in the works right now. So I haven't decided exactly how that will work. Okay. Uh, so as you might remember, we have this mind body problem that goes way back. And one of the founding basic question is how do mind and body relate? Um, what part of the body is related to thought? There was a cardiocentric theory that was popular among, well, in many cultures. It just feels like your experience is in your chest. We have visceral feelings, emotions, and so on. So there was this cardiocentric theory of mind that you know Aristotle seems to have held, and Empedocles and other ancient Greeks. Actually, Aristotle notoriously wrote at one point that it was the brain that was like a radiator, uh, and so your passions, which you have in your heart, go up to dissipate heat in the radiator of the brain. So the brain is not necessarily what's thinking and driving motion and receiving data about the world. It's more like a radiator. It's radiating heat. Uh, and he and others thought these things for different reasons. Aristotle was trying to be empirically responsible. So he noticed that, for example, a jellyfish can sense the world and move. It can flee a predator and pursue a prey without a brain. It doesn't have a brain. So the brain, that's not what brains are for. Um, and again, the brain itself is wrinkly. It has a lot of surface, and things that have a lot of surface for their mass radiate heat, right? So he did have some empirical reasons for believing that that's the job of the brain. There's also this interesting question about where thought occurs, given that it does occur in the brain, because plenty of people thought it did occur in the brain. Uh, and and when you dissect a brain, you'll find cavities, and some people will think of the soul as kind of a wispy, gaseous, kind of entity that maybe flows through these cavities in the brain, right? And and so you have um, uh, people that are trying to understand the world better. We really didn't have science as we understand it today, but you have people that were trying to understand the brain and just the world in general, thinking that thought occurred in these cavities. This image over here kind of exaggerates those cavities. They're not actually that big. And I guess I can go back and say, what do I want to say? Um, so uh, uh, there were in the European tradition, there were prohibitions against uh, cutting up bodies, and not that it never happened, but it was not as common, uh, and so dissection of the brain was not as common. But the notion that the brain is crucial for thinking goes way back to hundreds of years BC, like 17th century BC, that the Egyptians had records about how um, arrows that injuries to the brain caused by arrows, for example, in battle, might bring about aphasia, which we're going to problems with speaking. We're going to look at today, and seizures. Okay. Uh, what's this over here on the left? Can someone tell us this image? McKay, go ahead.
Is it trying to map like what the roles of each section of the brain do?
It is an attempt to do that. It's an attempt to map the brain. It was not especially scientific. Does anyone know the name phrenology? I'm going to put that in the chat window, even though it's going to be later in the slides. Uh, Phrenology was kind of a pseudoscience. It was an attempt to map, uh, to localize cognitive capacities. So here you can see caution, and most of these are hard for me to read, but this is caution here, and this is hope, uh, and I think that says acquisitiveness. I don't know. Anyways, the idea was that you could localize, and we're going to learn more about this in a moment, cognitive capacities. And there's certain the regions of the brain that, if they're more developed, will result in having a more advanced cognitive capacity. Now, that's a kind of localism, but you don't have to be a phrenologist to be a localist. Okay, so there are more uh, because I said this was regarded as a pseudoscience. It's been pretty much debunked. I don't even know why I said pretty much. It has been debunked. Um, and yet there are good reasons to be a localist of some kind, just not a phrenologist. And so there's been this debate between localists and holists. And sometimes the localist is a localist just about a certain type of cognitive capacity, and other times they're just localist, period. And the same goes for the holists. But you could be a holist about some capacities and a localist about others. And I think personally that's probably the most reasonable stance to take. Uh, there were other questions about the basic functional structure of the brain and how neurons work once we discovered neurons. These are brain cells. Uh, and so let's get into phrenology. So Franz Joseph Gall uh, uh, is is the one who promoted what came to be known as phrenology. He preferred craniology as uh, the term for what he studied. And he made some advances in anatomy. He showed that brain size and mental development were correlated. Uh, and he also believed that by looking at bumps on the skull, you could figure out a person's cognitive capacities and what they excelled at and what they were deficient in, etc. So if a person had, say, a bump right here where it says caution, they would be a more cautious type. The idea is the brain gets overdeveloped in certain ways, and it literally gets like buffer, like bigger. And that in your development, that actually distends the skull. It pushes out the skull. That's what he thought. Okay. Now, virtually all of this we know now to be false. Science has shown it to be almost everything that in what I just said is now known to be false. Uh, but the the foundation on which it rests is localism, and uh, we we can support localist theories about some things. It's about we have a pretty strong case to make. Uh, uh, but here, these locations are manifested by greater mass of tissue. There's only a very tenuous sense in which that's close to the truth. If you engage in certain cognitive tasks a lot, your neurons, brain cells, will develop more dendritic spines and more dendrites, uh, and so you can change the structure of your brain, and that's what you do when you think. Every day, the structure of your brain is changing, and this is based on what you do. So, for example, cab drivers back before there was Uber and Lyft, et cetera, and also before there were smartphones, they knew every, in London, I think it was done in London, um, they knew all these little side roads and alleys, and they carried in their heads virtual maps of London, and it could be showed that certain areas of their brain were altered as a result. Now that doesn't mean that there was a greater mass of tissue, but there was that change. There is that change in their brain. It also he was simply wrong when he thought that a greater mass of brain tissue would distend the skull and create these bumps. Uh, but he did. I think he was sincere. He did think he was doing science, and let's see. In a sense, his theory was prescient because he was because localism of a kind is pretty well supported now. But his method was pre-scientific, to say the least. It was based on anecdotes and very likely infected by confirmation bias. And can someone tell us what confirmation bias is? Science is effectively a war against confirmation bias. So, anyone want to tell us what that is? I'm hearing something. I don't know if someone was trying to speak.
Um,
There you go. I hear.
I think like the best way I can explain it is that you you take everything as evidence for something that you want to be true, and it's just like an unconscious bias that you have, especially
That's
if you have like some like money in it, you know.
Well, yeah. So before the money, yes, we like to be right. We have cherished beliefs. We like to have evidence in favor of those. So you well put. That's confirmation bias. Also, on the other side, if there's something you don't want to believe, then you start looking for disconfirming. You look for ways to debunk the things that you don't like to believe. That's confirmation bias. And then there are other motives. For example, money. Um, might motivate you to even be more prone to confirmation bias. Uh, uh, and right, and Zaw says new evidence is confirmation of their beliefs. So you might cherry pick the data. That is, you go after the data that you like, that supports your view, you ignore the data that goes against it. And this is just how we're built. We are very prone to confirmation bias. And I think that's part of why it took so long for people who are sincere investigators of the world, right? Philosophers, mathematicians, um, people interested in cosmology and astronomy and history and literature. I think this is why it took us so long to get science. It's really weird if you think about it, but for almost all of human history, including almost all of civilization, we didn't have any science. We had, of course, there are people who are just corrupt and self-interested and all that, but among the people who really wanted to understand the world and were sincere and made efforts, they still didn't necessarily have science. It's only a few hundred years old, which is just, if you think about it, that's so strange, right? Um, Estella says, we tailor our social media account to show us what we want to see or learn. Yes, and it's also done for us, right? So we have these algorithms that kind of wrap us up in a bubble where we're fed um, we what we've taught these algorithms we are interested in. And it's one thing to say what you're interested in, but the algorithms often know otherwise, and that creates, as Layla says, echo chambers, right? So it's a we have to make great efforts to resist this. Um, and I think it's just look at history. It took so long for us to get anything like science. And then once we started building, a kind of scientific methodology, and scrutinizing our beliefs more carefully, um, it's still an uphill battle. And even people who praise science and even scientists themselves are subject to confirmation bias. So, what do you do if you have a scientific hypothesis? You have a theory about how the brain works or whatever. What do you do? Well, one thing that many scientists will say is you test it, which means you look for evidence that goes against it. You don't just collect the evidence in favor of it. And that's just it sounds negative. It sounds hard, right? But we just saw a few classes ago, we saw um, the different theories, two different theories of attention. And Broadbent's theory was immediately tested. Does it predict the cocktail party effect? Apparently not, right? It doesn't. So you find reasons to reject the theory. But that's actually good news for science because you're making progress, because you're learning, okay, this doesn't work. And science is not a linear progression. It's kind of like evolution. It's a branching process with a lot of dead ends. Okay. So that I kind of gave a long spiel about science and confirmation bias and what was Gall probably doing? Well, he was probably noticing that, like anecdotally, certain things. So there's an anecdote that he tells about a student he had who had bulging eyes, right, and a good memory for vocabulary. Okay, so Gall at some point thought this student is really good at memorizing vocabulary, and this student has bulging eyes. And from that, he thought, well, maybe your brain, the location of your vocabulary memory is behind your eyeballs. And this student's brain is buffer in that way, is larger in that area, and it's pushing his eyes forward. Okay. Now let's say you think that, you sincerely believe it. I'm not saying that he was falsifying data. Um, and Yes, a slippery slope type of thinking. So then he starts looking at other people with bulging eyes, and the moment they give any indication that they have a good vocabulary, he goes, "Aha, see, that's exactly what I predicted." And if you find someone with, they have a good vocabulary or memory for vocabulary words, You might be more inclined to see them as having bulging eyes when they don't necessarily, right? How would you test this? Well, you try to come up with an independent way of measuring both. So you'd give vocabulary tests, and then you'd have some kind of way of measuring people's eyeballs, right? Independently. So when you made the measurements of their eyeballs, you would do it in a way where you have no idea what their vocabulary scores are, and vice versa, right? So you'd make these measurements independently, and then you look for a statistical correlation. And guess what? My money's on there's no such thing. There is no correlation, uh, positive or negative. Now that could be wrong, but that's how you would resolve this scientifically. And back in those days, they just didn't know enough about the need to be that rigorous. In fact, and this is kind of fun. I'd love to teach a little section on it. One of the things that has made scientific methodology more rigorous is the fact that many decades ago, starting around the time of William James, around the turn of the century and into the first half of the 20th century, many scientists fell for uh, uh, misleading indications of psychic activity. So there were scientists who thought that people who claimed to be psychics had actual psychic abilities. And they didn't realize that the tests that they had these psychics perform, that the scientists were, whether they knew it or not, they were colluding unintentionally, sometimes sending signals to someone who's supposedly reading cards, for example. Uh, and uh, it was the fact that scientists themselves, who were trying to be rigorous, that they were being misled by these experiments that led scientists to be even more rigorous, to develop more rigorous uh, methods. Uh, Mesmerism. Okay, so one more point on this. Um, Mesmerism was there was this guy Mesmer, and um, he claimed to be able to uh, put people in certain states, um, and this would cause them to get rid of maladies and so on, ailments. And it was Ben Franklin when he visited France. It was Ben Franklin who suggested the first double blind, or I'm sorry, first blind experiment, where you don't know who has been mesmerized and who hasn't. And so you're testing this objectively instead of going in knowing that this person over here has supposedly been mesmerized, and then allowing confirmation bias to infect your description of that person. Okay. Um, so thanks to those events, those incidents, science has become even more it attempts to be more objective, more rigorous than ever before. And so Gall was probably just in the grip of this uh, cognitive bias in thinking this. Now I'm going to check my notes. Okay, so I said that it's regarded also as a pseudoscience, and I like to be a little more careful because sometimes the pseudoscience just means bad science. Um, but if you want to respect the original term, it means something dressed up as science that is mainly untestable and therefore not science. So how do you make something untestable? Um, you you protect it from making predictions that could show it to be false. And that's actually uh, not what, say, Broadbent did. Broadbent did not protect his theory from being falsified. It was falsifiable. And when we say falsifiable, we don't mean creating fake data. When someone falsifies data, we mean refuted. You can refute it. You can show through experiment that it's false, right? Uh, and and so uh, Gall's theory is actually falsifiable. So I personally wouldn't call it pseudoscience, although a lot of people do. I would just call it bad science or science that turned out to be refuted because he actually does. He says, look, people, he makes testable claims. Cautious people will have bumps here. Hopeful people will have bumps here, et cetera, right? Well, we can test these things. And in fact, to some extent, we did. And guess what? They turned out to be false, right? So its own predictions were not met, right? And so, in fact, uh, Florin, uh, Marie Jean Pierre Florin, um, kind of stands on the opposite side of this, and he tests phrenology by vivisecting animals. So he removes parts of their brains uh, and then compares their behavior with normal animals, and he finds out that this area that is supposed to represent caution, when removed, doesn't change the animal's behavior with respect to caution. And so there are all these predictions that phrenology made that just were shown to be false. And so that's why I wouldn't call it a pseudoscience, but a lot of people would. It's just an attempt to do science. It's a hypothesis that turned out to be false, disconfirmed. Yeah. Now Florin um, takes that and goes all the way into holism, and he writes um, all sensations, all perception, all volition occupy concurrently the same seat in these organs. The faculty of sensation, perception, and volition then is then essentially one faculty. So he is a holist, at least about all of these things, and that's a lot, right? He's talking about sensations and perception and volition, right? Everything. And I think we can safely say they're both wrong in important ways. So one example of an early reasons to be a localist comes from Broca and so-called Broca's aphasia and Broca's area uh, in the brain. Um, uh, the what he reports on had been known by others, but he's the one who got this aphasia named after him. Um, So there was this man who at some point in his life lost his ability to speak, and he showed indications of being intelligent, but he just couldn't produce words of his own language. In fact, there were only there he would say the word ton over and over again, and he would show a lot of frustration. And it was pretty clear that he had something he wanted to express, but he would just say ton, ton. And then every once in a while, the only other thing he could say, and he could say it quite fluently, was a string of curse words. So he'd be trying to express something, he'd get frustrated and he'd curse fluently, but he couldn't ever get the sentence out other than that. Uh, and Broca, because of his knowledge and research, hypothesized or predicted that he would probably have a lesion in his brain about here. And sure enough, he does on the frontal left lobe. He dies, and an autopsy showed that he had a lesion right there. And he observed a bunch of cases and came to, hypothesize that this region, the left hemisphere especially, but some part of the left hemisphere encodes this language capacity, which is the ability to produce language, not necessarily the ability to understand it, right? And we're going to learn that these that some of these capacities are localized, or at least that we have good reason to think that. So I'm going to share with you a video that makes this point. And you want to know this video. The person in this video is Sarah Scott. It'll be up in a moment. And we no longer tend to call it Broca's aphasia. Aphasia, by the way, is having some speech or language impairment. And we call it expressive aphasia because she has trouble expressing what she wants to express. So sharing computer sound. And then you'll have these links if you don't already. I don't remember if they're linked in this week. Okay, so this is Sarah Scott uh, and we'll hear from her. She has expressive aphasia.
Okay. So what's your name?
Scott. Oh, no. Sarah Scott.
That's right. And how old are you?
I can't.
Try.
I can't.
Oh. You're 19. 19.
Yeah.
Yeah. And what happened to you?
Stroke.
You had a stroke last year.
Yes.
And what happened? Can you remember what happened?
How would you describe what's going on? Does she have a motor problem? Is she unable to move her lips, tongue? Is she slurring her speech?
It seems like she can't access some words.
Seems like she can't access some words. Thanks, Jessica. What do you mean by that? Can't access? Like in her head?
Um, it seems like it. She can say some things, but other things are like inaccessible.
She seems to fluently say, "I can't, I can't," and yet she doesn't know her own first name.
Well,
Um,
it seems like she knows, but she
yeah,
can't say it.
good. Yeah, that's a better way of putting it. She knows she can recognize it. She can understand what her mom is saying. She doesn't seem to have any confusion about what her mom is saying. Uh, she can't say how old she is. It's like, as Jessica says, it's like she can't access these words. We've all had that tip of the tongue phenomenon where you're trying to remember a word and you can't. And maybe that's what it's like to be Sarah Scott, but for more words, more often. Jerome says she seemed to be able to write it no problem. And that's something we're going to see. Okay. She has this notebook with her. So pay attention to what goes on. I'm going to back it up a little.
19.
Yeah.
Yeah. And what happened to you?
Stroke.
You had a stroke last year.
Yes.
And what happened? Can you remember what happened?
Um, School and English class,
Okay.
and I book, and I read it aloud, but I can't because stroke, and so I turn and also it's the same as the same of kind of thing as you know.
Pins and needles.
Yeah,
like pins
the
and
same, and also as well.
So she's trying to express that she was in an English class and she had to read aloud and she couldn't. And she also had pins and needles on one side of her body. Which side?
The right side?
On the right side of her body. That's right. And so she says her right arm, her right leg. And the interestingly, it's the left hemisphere of the brain. So the brain has two hemispheres, right? And then there's this bridge between them called the corpus callosum we're going to learn about. The left hemisphere, for some reason, is largely in charge of the right half of the body. In the right hemisphere, so you have this crisscross, they call it contralateral, right? The right hemisphere is largely in control of the left, right? So, damn it, if you ever get pins and needles on one side of your body, and it's not because you slept funny, but if you ever have that experience, uh, you could be having some kind of stroke in the left hemisphere. And for most of us, not all of us, but for most of us, that's where language is. At least the capacity to produce language, not the entire capacity, not all language capacities, but the ability to produce language, left hemisphere. And did anyone notice that she wrote in her notebook? And did anyone have an idea what's going on there? Because Jerome says she seemed to be able to write it no problem.
I was thinking maybe writing it would it like help her speak it maybe, or it makes it easier for her to speak it.
Yeah, and that she's going to say so much in just a moment. So let's go back a little and think about that. What would it be like to not be able to produce a word verbally, but be able to write it and then learn and then read it aloud? Because that's what we're going to see. Watch.
Kind of thing as you know,
Pins and needles,
yeah,
like pins
the
and
same, and also farmers, but
needles. Leg.
yeah, yeah.
And what happened after the stroke with your speech?
But I can't.
You have speech problems.
Yeah.
Do you know what that's called?
Yeah. Aphasia.
Yeah, good, good. I haven't heard you say the word before.
I write it down. Because,
And that helps.
yeah.
Okay.
So wait. So she's not able to recall the word and use it verbally until she writes it. She's able to write it down. And then she's able to read it. It's almost as if there's a part of her brain that retains the word and can recall it for the sake of writing it. And the part of her brain that can recall it that should recall it for the sake of speaking it is not functioning. It then looks at the word and goes, "Oh, aphasia." And by the way, I hear it pronounced aphasia and aphasia. I'm not sure if in the UK it's the norm to say aphasia. They say aluminium, and have other, ways of pronouncing things, of course. But in the United States, I think the norm is aphasia. Okay, so this is pretty strong evidence for a kind of localism that her ability. She did have a stroke in the left hemisphere of her brain, and we can at least say this. We can say that area of the brain is essential for you must have a functioning part of that part must be functioning for you to be able to produce language. Can parts of the brain heal similar to other parts of the body? It depends on what you mean by similarly. So until throughout most of the 20th century, scientists believed that we did not regenerate neurons. It used to be taken as a law that the only cells in the human body that don't regenerate are neurons. Skin cells regenerate, even bone cells, right, etc. But then it turned out in the late 90s, we had good evidence to suggest that actually sometimes brain cells do regenerate. And I was once at a cognitive science conference where a guy was giving a talk, and he, in an offhand way, he said, "Oh, by the way, there's research that brain cells regenerate." Totally derailed his talk because everyone in the room was raising their hand and saying, basically that's bull, right? Because it was just the standard view that brain cells don't regenerate. But we now know that's not the case. They do. So that's one way that we get kind of healing. But also when brain cells don't regenerate, when you have a stroke, the surrounding neurons they will form new pathways. They will create new dendrites. And so the surrounding areas will accommodate. And that's why sometimes stroke patients can regain their abilities.
Oh.
Araceli's, oh, go ahead.
I was okay when I typed that out. I was kind of thinking that I was just thinking in
Yeah.
my head like her going through the process of writing things down and then being able to speak it. And I was just thinking, if she was to continuously do this, would she be able to recover and get better at it, you know? And I was also kind of thinking, is it similar to like a muscle, you know, how certain muscles, you
Yes,
know, you use it and you stress it over, you know, you use it a certain amount and then it gets stronger over time, you know?
it's
Does it work similar
yes.
to that?
Yeah, thanks, Jerome. It's broadly like that. I mean, in the case of the muscle, you're literally making it buffer, making it stronger, and something different happens in the brain. It's called neural plasticity, and so the neurons take on different functions, and they do physically change. Um, but yes, the in both cases, whether it's muscles or cognition, producing speech, using the capacity makes you better at it. And that's just important to know that you will the more you do whatever you do, the better you'll get at that. Even if what you're doing is not a good thing, right? So the more you rehearse negative thoughts, the better you'll get at rehearsing at what's called ruminating, right? Um, and and the more you practice singing, and the more you practice dancing, the more you think about what ifs and hypotheticals, etc., the better you'll tend to get at those things. Um, do I want to say a little bit more? Uh, okay, yeah. So Sarah Scott had her stroke in 2009, and I've been showing this for a long time. I don't know if it goes back to 2009, but she's doing a lot better. And yes, I do have one more thing to say in response to what Jerome was saying. Um, uh, for about a generation, doctors did not know that if a child has an atrophied limb due to polio, because we had that was a big problem long ago, or some other condition, okay, what they didn't know was that they should be encouraged to use that limb which is atrophied, which means weakened uh, in a muscular sense. And I forget the doctor's name who did this, but he had an insight and he thought, I'm going to tie down the other arm of this child so they can't use their good arm, the arm that's not affected. So they have to use this atrophied arm. Uh, and even in a matter of days, they start to regain functionality, right? And so that's very important to know. If you do have a stroke, I mean, all physical therapists know this now, but we didn't know that back then. So we lost a whole generation of people who could have, especially when they were children, exercised their atrophied limb more effectively and regained a lot of function. Um, okay, and the same goes with cognition. Now, it's not always entirely something you can recoup. You might never get back to 100%. You might have trouble getting even to 50%. In some cases, the injury itself is just way too traumatic. Um, but in a lot of cases, there are improvements. And so Sarah Scott continued to make these videos, and she is now a grown woman in whatever in her uh, well, it's been 10 years. So in her late 20s, early 30s, it's been more than 10 years. Um, and so you can find more videos on this, and it's fortunately a kind of a happy story. Araceli says, so localism is real, but that one scientist was way off. Um, uh, yes, phrenology is false. So Gall was wrong about that. But localism is real in to an extent. Yes, there are areas where if you get damage to that area, we can all predict what capacities, what cognitive capacities or mental abilities you will lose or have a great difficulty with. We can make really good predictions on these things. Um, now, the critic will say this. They'll say, but you haven't shown that language is encoded just there. All you've shown is that that region is required for the language production. But that doesn't mean that language production isn't a more holistic thing. And I think the localists have to say, okay, we'll grant you that, but still we have a kind of localism. It's this region is required for language production. Yeah. Let's watch just a little bit more. And I want you to remember a few things. So what it's like this is a philosophy course, okay? So in addition to learning these basics about aphasia, expressive aphasia, I want you to think, what would it be like to be Sarah Scott? And we all know what it's like to have a word on the tip of the tongue. You're trying to recall it. You know that if someone says it, you'll recognize it. You know that under other conditions, it just comes to you. But it's just not right now, right? It seemingly that's the kind of problem she's having for far more words. She's not slurring or mumbling. She doesn't have any kind of motor problems. She doesn't seem to have any trouble understanding what her mom is saying, right? So it's a very isolated impairment. She has trouble recalling, or as Jessica said, accessing these words mentally. Now thinking about it, I've experienced aphasia when I had a migraine before. Yes, sometimes, thank you, Octavia. And if you want to say more, go ahead. Sometimes my students share their own experience with episodes, whether it's a migraine or something else. And a migraine involves temporary loss of functioning in brain areas. Did you want to say more?
Yeah, I can. I was just a
Okay.
really bizarre experience because this is when I was a kid and I was in summer camp, and for some reason I couldn't say any of the words I wanted to say. And I was like, it was like a blurb speech. Like I was like, "Brr, brr, brr, brr," and I like was thinking of the words and I was like, why can't I say these words? And one of my friends at camp was like, thought I was pranking her, which was really, I was like, I don't know what's going on. So I had to like get a piece of paper and write down. I was like, I'm experiencing a migraine. I cannot speak right now. But I was thinking all
Wow.
of the words, but I just couldn't like say any of them in a proper way. And I could say some of them if I like really tried hard to like write them out and say them. But it was the most bizarre thing. And it was just like, and I didn't know how to explain it too, because I was younger and I was like, I don't know how to tell anyone because I can't say any of these words. So it was really weird because I thought I could do it. I thought I could speak and then I would try and then it would just come out jumbled.
And interesting, Otavia, you recognize that it came out jumbled? Yeah,
Yeah.
okay. Because that's not always the case. I'm going to give an anecdote in a moment. And you were also able to write things down?
Yeah. I was able to like write some things down. I think it was like kind of hard for me to write things down, but it was like I could still like do it.
Wow. Wow. And I'm guessing it was also kind of scary, uh,
Yeah,
or
it
frustrating.
definitely
Yeah.
was. Also, I have never experienced anything like it after. It was just that one
Mm.
like isolated incident to talk
Wow.
about.
Yeah. So you just answered Estella's question in the chat. So my own mother had a similar instance because she had TIAs, transient ischemic attacks, which are like mini strokes. She had that experience. So I've talked with her about it. Unfortunately, she's doing a lot better. And the neuroscientist on my PhD committee, Bruno Olshausen, he's at Berkeley. He's a neuroscientist. And one day he realized that something was off and he managed to get himself to the emergency room at a local hospital. And he tried to say, I'm having some neurological problems. He thought he was saying this. He thought he was speaking coherent English, and everyone was looking at him going, and he kept saying, can you not understand me? What's wrong? And everyone's like looking at each other, and then he has to kind of infer that although it feels like I'm speaking English, I must not be, right? And he even at one point wanted water. He felt very parched, and so he'd accepted that, okay, I must not be speaking English, even though I thought I was. And so he tried to pantomime, I like water, right? And even that did not get across. And so what I would love to know, we discussed this, is so we know that there are versions of this for people who use sign language, right? So if Sarah Scott had been a sign language user, then maybe she would have trouble recalling the signs to say the things that she wanted to say in sign language, right? And we know this is the case, that people who use sign language can have the same effect. Uh, and so what we don't know, and what I would love to know, is when he thought he was doing this, was he not? Was he doing something else? When he thought he was gesturing to his throat, was he not? Because I think anyone at a hospital who sees someone doing this is going to know, obviously, this person wants to drink something. Um, Unfortunately, he didn't ask them later, did I make sense with my hands? And he was better also. He had a kind of what they called a wave of depression, where the activity was very low for some reason, kind of swept across his brain, and it fortunately didn't have any um, uh, permanent effects. Um, so so this is relevant to the next video that we watch. Okay, you can think you're expressing yourself in a language and be wrong. Okay, let's watch a little bit more. And thank you, Tavia, for describing that. Now, Sarah knows that she has a deficit. Like, she knows when she can't recall the word. So she's not in the state that Bruno Olshausen was in, and she's not in the state that this next person we see is in.
Aphasia.
Yeah, good, good. I haven't heard you say the word before.
I write it down. Because,
And that helps.
yeah.
Okay. So you are going to go to university. What are you doing now?
But
What do you do now? Every day?
I'll speech, then the speech.
Therapy?
Yeah.
Okay.
And
So I'm going to let you watch the rest on your own if you like. We only need to watch up until here to get a sense of what her impairment is like. And now we're going to watch an example of another kind of aphasia, not expressive aphasia. So this is expressive aphasia. It used to be called Broca's aphasia, named after Paul Broca. The next one is fluent aphasia, and it is sometimes called Wernicke's aphasia. And a lot of Americans say Wernicke. But if you want to pronounce his name the way he pronounced it, it's more like Wernicke. And so this is Byron. I'm not sure if it's Byron or Brian, because I think his name tag says one thing and you hear something else. Anyways. Fluent aphasia.
Hi, Byron. How are you?
I'm happy. Are you pretty? You look good.
What are you doing today?
We stayed with the water over here at the moment and talked with the people for them over there. They're diving for them at the moment. They'll save in the moment. He'll have water very soon for him. With luck for him.
So we're on a cruise and we're about to
We
get to
will
June.
Okay. How does his condition differ from Sarah Scott's? And we'll call him Byron. Does he seem to show the frustration that Sarah Scott shows? No, Sarah Scott knows she has an impairment. He doesn't seem to know that he's not expressing himself. He has plenty to say without frustration. He can speak, but it's jumbled. That's right. We will sort right here and they'll save their hands right there. A lot of what he says makes no sense. Yasmin, go ahead.
Sorry about that. So is this something that you see in dementia patients as well? This sort of the way he's speaking, but it makes no sense, right?
I don't have I don't have any clinical education. So
Mm.
my understanding is it is different, but I think, yes, dementia patients say things that don't make sense. And it might be the case that dementia and Wernicke's aphasia are comorbidities. I don't know. but I wouldn't be
Okay.
surprised. Yeah.
Yeah. So
But
yes, he doesn't make sense. Like the subject matter, the subject is jumbled.
yes, and the I mean the diction is way off, right? So the words that although they might be part of grammatically correct phrases,
Right.
they don't apply to anything.
Right.
Um, yeah, and it's quite jumbled. So to go back, let's see, right? Notice that in locally, usually the grammar is preserved, like the moment held water very soon. Okay, that doesn't make sense, but the nouns and the verbs and all that are matched up. But then when you look at the entire sentence, it's kind of a word salad, or maybe I should
Yeah.
say a phrase salad. Yeah, good. Uh, and Byron seems to think that he's conversing, like my advisor, Bruno Olshausen, during that episode. He seems to think that he's being understood. He's expressing himself. Uh, and he's doing it fluently. That's why they call it fluent aphasia. Uh, I like to think of it this way. If you didn't speak English, you spoke some other language, and you saw Sarah Scott and Byron doing what they do, you see Sarah trying to speak and halting and showing a little frustration. You see Byron speaking fluently. Which one would you know probably has some kind of speech impairment or language impairment? And the answer would be Sarah Scott. And you would have no way of knowing that his English is coming out as gibberish until maybe you saw the faces of the other people that he was trying to communicate with. But not, I mean, there's nothing intrinsic to what he's doing that would give it away if you don't know English. Let's watch a little more. We're going to watch all of it, actually. By the way, sometimes what he says is indicative of what he's thinking to an extent, right? So they're on a cruise, and he did mention water. Um, and uh, at the beginning, when she asks him how he is, he says, "I'm happy. Are you pretty?" So he might be thinking something flattering about her. And just pay attention as you go through this.
With luck for him,
So we're on a cruise and we're about to
we
get to
will store it
Juneau.
right here, and they'll save their hands right there for them.
And what were we just doing with the iPad?
Right at the moment, they don't show a darn thing.
With the iPad that we were doing. Like here?
I'd like my change for me and change hands for me. It would happen. I would talk with Donna sometimes. We're out with them.
That's something that happens too. I would talk with Donna sometimes, a perfectly coherent sentence, right? Even though it comes along with these mysterious utterances.
Other people are working with them. I'm very happy with them.
Good.
This girl was very good and happy. And I play golf and hit other trees. We play out with the hands. We save a lot of hands on hold for us, other hands. I don't know what you get, but I talk with a lot of hand for him. Sometime. Am I talk of any more to saying?
All right. Thank you very much.
Thank you very much. I appreciate it, and I hope the world lasts for you.
I hope the world lasts for you.
Thank you. It's been a pleasure. Bye-bye.
Have a good day.
Yeah. So that is, yeah, it's funny. Arceli says ominous. And I know some people that sounds scary to them. To me, it sounds very sweet. But I get it. I get the spooky version as well. So that is Wernicke's aphasia. And I want you to remember these two names. So we have Sarah Scott, who has what used to be called Broca's aphasia, now expressive aphasia. And then we also have Byron. I think I remember, it was hard to see, but I think his name tag makes it look like his name's Brian because someone typed it incorrectly. And then Wernicke's aphasia, and I'll put the slide up that describes that in a moment. be a little careful with these maps, these brain maps, because this might make you think, okay, the area has been identified. It's right exactly there on everybody's brain, but that's not true. So where Broca's area is depends on the individual, but it's usually around there. How big it is, et cetera, the shape exactly varies. There's a lot of variation. And the same goes for Wernicke's area. So in this case, they represent it as just kind of a elongated blob, and sometimes it's like a backwards C. It's sometimes it's covers more area. So it just kind of depends on the individual. And but this is about as local as you could hope to have, right? These regions are essential for those capacities. Damage to Broca's area will very likely make you more like Sarah Scott. Damage to Wernicke's area will very likely make you more like Byron. Okay. Now, there is plenty of other evidence for this kind of localism. And for example, you may have seen what's called the motor or the sensory homunculus in a textbook. And you can now buy these really kind of creepy homunculus statues, like your neuroscience professor might have one on their desk or something. And the hands are huge, and then the arms are very small, and they're meant to like represent a kind of one-to-one correspondence between areas in the brain responsible for those parts of the body. Okay, Jerome, go ahead.
So when you're talking about it being localized in different parts of the brain, when we're talking about all of this, I've been thinking about CTE, like the brain injury that a lot of sports players get. And I remember a couple of years ago for a class, I was doing some research on it, and I remember reading that certain position groups and certain sports players will have different conditions or different symptoms when they have CTE, after they study their brain, They were noticing that a lot of football players, I think when I read it, it was particularly players who play on the offensive and defensive line who are constantly
Yeah.
bumping like the front of their head against one
Yeah.
another. They would be more violent, and then other people would able to
Yes.
have different type of symptoms when they played on different positions of the field or if they played in different sports. And another like little anecdotal thing that I think we all kind of notice this, even if you've never taken this class and you never studied it. If you're on Twitter, there's a player, Michael Irvin, who was a wide receiver, and he'll do all kinds of crazy things now. He'll be on like the broadcast shows for Fox and all of that. And he'll be like barking like a dog on the sideline and do all kinds of crazy things. And on Twitter, people will joke and be like, he got the fun CTE. And other people will have, other examples of it. So I think we all kind of notice this kind of localization thing, even if even if you're not aware of it. So.
That's a great example illustration, Jerome. In fact, right, the damage to the frontal lobe results usually in a lack of inhibition. It's the frontal lobes that are responsible for executive function, inhibition, and judgment, among other things, right? So damage to the frontal lobe does tend there's a correlation with that and what's called not just violence in general, but I think it's called impulsive violence, right? And so if you can't control your impulses, and we all have, whether we acknowledge it or not, we do have these impulses to do rash things, and sometimes we just have no idea, how quickly the executive function, um, the frontal lobe, prevents that, inhibits that rash action. But yes, damage to the frontal lobe can result in being less inhibited, and sometimes that can mean you're more entertaining, and even in some cases more creative. But it can also mean that you might be more rash or even more violent. Um, Good. And Layla wrote about this homunculus with huge hands and tongue. That's right. So the tongue is very important. We use it to taste and to eat, but also to speak. So it requires a fair amount of brain region, right? And the face, of course, we're social animals. So we need, this is the motor strip right here. And notice that the sensory strip devotes more to the lips, right? So that it's more important that we sense with the lips. This is maybe a little counterintuitive than that we control the lips. You might think, well, if we're speaking, we need to have a lot of control, but apparently we have more brain region applied to the somatosensory aspect of the lips, sensing with the lips, than controlling the lips. And the hands are huge because we are so dependent on our hands. Our hands uh, require so much more brain area than, say, your forearm. And what do you do? You have some muscles that they flex, and that's about it. But with the hands, there are all these things that you can use your hands for. So again, more area, and then hardly any area applied to like your leg, your thigh, and your lower leg, right? Uh, there was a hand up. If you want to go ahead and ask or say something.
Oh, it was me, Dr. Blackman.
Yeah.
I had this conversation with my doctor the other day because I injured my hand, right? And they had to
Yeah, I
have
remember.
surgery on it. And it's my right hand, it's my dominant hand. And I said to him, I go, what's really, I'm trying to write with my left hand and do everything with my left hand. And I said, what's so hard is that I'm realizing I almost feel like I'm in a brain fog. And I said, I don't understand it because I can't, like, when I'm writing with my left hand, I'm writing, but I'm so focused on just trying to write the letters and the words
Yeah.
that it takes so much energy. I said, I just feel so disconnected. I said, is that normal? That he goes, he said what you basically said. He's like, you don't realize how much of your brain is dedicated to your hands. And of course, your dominant hand's your right hand. So he's like, this is why you probably feel like you have brain fog, is like you're not able to absorb the information the way you did before, or like there's definitely something changed and you're going to have to adapt, right? For now.
Yeah.
So it's so fascinating. I just never thought about it.
Right. And I think there's pretty good reason to believe that uh, our ability to use our hands plays a big role in just in thinking when you're doing that kind of language processing. And so if you're not able to use your hands, that can impair your thinking. That can make it harder for you to do what you were so used to doing. That's interesting. And I hope you recover well. Sorry you had to have surgery. Um, what else can I say? Um, yeah, I covered that. Check my notes. Okay, so to blowing this up, this is what we can pretty reliably say about the brain. You have areas, vision is processed back here in what's called the occipital lobe. Uh, there's a lot of language going on in the left hemisphere, but not entirely for most people. Executive function in the front, and then we have auditory areas and emotional areas. Okay, but don't take these regions so seriously. It makes it look like you have clean lines, like you're breaking up the United States into different states. Not necessarily. In fact, in neurosurgeons, right, who might have to remove an area, they have ways of trying to figure out where your language area starts and stops. And the ideal way to do brain surgery is to have the patient awake, so that they can talk to the patient as they are stimulating or anesthetizing areas. And if they're about to remove something, and when they stimulate it, it becomes evident that that plays a significant role in your language, they might think twice about removing as large a piece. So they're literally like playing. One of them described it as brain bingo, right? Just kind of discovering through trial and error what regions of your particular brain are responsible for. And remember what I said about Wernicke's area? Here it's 11, this pink colored, look at that, it's a big giant backwards C. So it doesn't look really anything like this thing here. Okay, so any particular map is going to make it look like they know a lot more than they know. These regions there's variability and they kind of bleed into each other. Okay. Well, there's one more that I want to share with you. I'm going to start it off because we've watched 2 videos. I'd like to watch the third one. And this is a patient who has an electrode in what's called the fusiform face area or the fusiform face gyrus. So here FFA is fusiform face area. You have an area in your brain, it's kind of behind and below the ear that is highly specialized in interpreting faces. Like I just said, we're social animals. So it's very important that you look at a stranger and know what their intentions are. And it's very important when someone says, I come in peace, that you also be able to read the expressions on their face and decide whether they're telling the truth or not. So we're good at emotions, we're good at expressions, and we're also just very receptive. We detect faces, right? A face in the bushes is going to be more likely to jump out at to demand your attention than something else in the bushes. So they're going to stimulate that area for this guy. And we're going to watch some, but not all of this.
Okay, just look at my face and tell me what happens when I do this, all right? Okay. 1, 2, 3.
So sham means they're pretending to stimulate the area, but they're not. Why would they do this? They want to establish that the patient isn't just going along with things, because that's what patients do, psychologists discovered, right? They start to suspect, I think the researcher is looking for me to behave in this way. And even when they're not trying to be deceptive, they will tend to play along with things. And so again, the doctor's going to say, here I go, I'm going to stimulate your brain. And half the time, no stimulation occurs, but the patient doesn't know. So if we do get a correlation, and if we get results only when it's a real stimulation, now we have better reason to think that it's legit. It's not just the patient saying what the patient thinks you want to say.
Nothing. Okay. I'm going to do it one more time. Look at my face. 1, 2, 3.
You just turned into somebody else.
Tell me
your
about
face metamorphosed. Your nose got saggy, went to the left. You almost looked like somebody I'd seen before, but somebody different. That was a trip.
Would someone want to tell us what did he just express to us? What happened in his conscious experience? The doctor pressed a button and he was instructed to look at the doctor's face, and he says the face just kind of warped. The nose went to the left, right? So he has a conscious experience of this doctor's face changing form. Not necessarily his memory, Jerome. They activated his face recognition area, the fusiform face area, which specializes in faces. They stimulated it in a way so it's not being stimulated by his eyes. I mean, it is being stimulated by what he sees, but then they added that additional stimulation, and that caused him to see a different face. Let's watch just a little bit more.
You see my eyes in place?
I could see your eyes, but you could have been somebody else who he has similar eyes to Dr. Parvizi, but you were someone else. Your whole face just sort of metamorphosed.
Metamorphosed. Did it get warped?
Yes.
Did it keep its own features?
No, it's
Or
almost
shape?
like the shape of your face, your features drooped. Yeah, sort of like they drooped to a particular direction, kind of stretched and drooped.
Okay, so we're going to leave it there, and we'll watch more of this in class. But you'll have the links to watch it yourself. We have very good reason to think that it's called what it's called because it's very responsive to faces. And damage to that area results in what's called face blindness, the inability that some people have because of the damage to recognize even loved ones, people close in their family. They look at the person's face, they can describe it geometrically, two dots here, a hole down here, etc. They can do that, but they cannot recognize the person. So that seems to be good evidence for localization as well. Okay, that's all for today. I'll see you guys next time. Thanks, everyone.
Thank you.
Thank you.
Yeah. I'm not exactly sure what you're saying, Araceli. If you want to unmute yourself, go ahead. I don't have too much time, but
I need to do more research and I'll get back to you.
okay. I'm interested in what you wrote. Okay, I'm going to end the meeting.
Bye.
Bye, everyone.